Hello and welcome to Video 8 in Module 2. In this video, we'll be discussing a certain type of graph called a stem and leaf plot. We'll also discuss two variations that you can make on a stem and leaf plot. Specifically, we'll discuss a split stem and leaf plot as well as a back-to-back stem and leaf plot. Let's get started. A stem and leaf plot is a good way to get a quick idea about how data are distributed. Earlier, we made dot plots as sort of a quick, rough sketch of a bar graph. Dot plots gave us similar information to a bar graph, but it took a lot less work for us to get there. A stem and leaf plot is similar with regard to a histogram. So a stem and leaf plot will give us similar kinds of information to a grouped histogram, but we don't have to do quite as much work to get there. In order to make a stem and leaf plot, we're going to take all of our data and break them up into two pieces, a stem and a leaf. So let's talk about how we can find each of those pieces. When we break a number up, the leaf of the number is the last digit. And it doesn't matter whether our data are whole numbers or decimals, the leaf is always whatever digit is on the rightmost side. Then we're going to break off all of the other digits and call that the stem. So the stem of a number is all of the other digits. Let's look at a couple of examples. Suppose I had the number 227. To find the stem and the leaf, think about breaking off the last digit, separating it from the rest of the number. In this case, all of the digits to the left of that red line are the stem. So the stem of this number is a 22. The leaf is going to be the 7. Let's do another example. Suppose I have the number 1.2. Again, I'm going to break off the rightmost digit. In this case, all of the digits to the left of the line are going to be the stem, so the stem here is just a 1, and the leaf is the digit on the right, so the leaf is going to be a 2. Once you get the hang of creating a stem and leaf plot, identifying the stem and the leaf is not going to be super tricky. It might feel a little bit weird now because it's a brand new kind of thing. Now, when your data consists of single-digit values, we're going to have to use the context of the rest of our data set to figure out what the stem and the leaf should be. So for example, let's say I needed to represent the number 5 on a stem and leaf plot. The way that I think about the number 5 is going to change depending on what the other values in my data set look like. For example, if my data ranges from 1 to 10, that means I'm going to have numbers like 8.7 or 2.6 or 5.3. In that case, it's probably best to think of the number 5 like 5.0. When we think of the number 5 as 5.0, then we'll chop the 0 off as the leaf, and the stem would be a 5. In other words, the 1's place is going to be where my stem is. However, suppose your data ranges from 1 to 100. In that case, we might have numbers like 87 or 12 or 38, things like that. In this case, I want to think of 5 similarly to the other two-digit numbers. In particular, the 5 has a 0 in the tens place, so I would think of the 5 as 05, kind of like you might see on a digital clock if it's 5 after 3 in the afternoon. In this case, when I break off the leaf would be a 5 and the stem would be a 0. In particular, now the stem is going to be the tens place instead of the ones place. If this is a little bit confusing, that's okay. This is one of those situations when once we see an example happening, it'll make a lot more sense. It's kind of hard to talk about it in the abstract, so let's work through a couple of examples and hopefully it'll make a little bit more sense. In this example, we've been given the lengths in minutes of the full-length animated Disney films that were made before 1980. We've been asked to both make a stem and leaf plot for these times, as well as to identify the shape. Okay, let's give ourselves some space to make a stem and leaf plot. Now, in order to make the stem and leaf plot, we need to identify a smallest and largest value. That'll give us an idea of how big to make our graph. When I look through my data, the smallest value is a 64, so I'm just going to write 64 over on the side. Then the largest value that I can see is the 128, so I'm going to write 128 off to the side. If I think about these numbers in terms of their stems and leaves, the 64 has a stem of 6 and a leaf of 4. The 128 has a stem of 12 and a leaf of 8. Now, to create the stem and leaf plot, we're going to organize the data by stems. In other words, I'm going to need a row for every stem between 6 and 12. I start by making a table where the first column is for the stems and the second column is for the leaves. My stems have to go from 6 through 12, inclusive, so I'm going to write those first. So my first stem is a 6, followed by 7, 8, 9, 10, 11, and 12. Now that I've got a row for each stem, I can start to fill in the leaves. Here's how we're going to work through that. My first data value is an 83. Remember, you can think of 83 as having a stem of 8 and a leaf of 3. To graph this number, I'm going to go in the row that has the same stem. So since 83 has a stem of 8, I'm going to go to the row that has an 8 in it, and I'm going to put the 3 in the leaves column. So that 3 that we see there represents the number 83. The next value in my data set is 120. And if I think of this breaking it down, it's going to have a stem of 12 with a leaf of 0. So I go to the row where the stem is 12, and I will write a leaf of 0. So that 0 represents the number 120. The third number on my data set is an 88. And here we have a stem of 8 with a leaf of 8. So I'm going to go in the row for the stem of 8, and I will write down a leaf of 8. Now notice that I didn't put a comma or any sort of separating mark between the 3 and the 8. Traditionally, in a stem and leaf plot, you don't put any symbol between the leaves. So we're going to just skip a little bit of space and continue to write our leaves out. Let's do one more together. The fourth value in our data set is a 64. So I go to where the stem is a 6, and I will write a leaf of 4. And that's how we're going to continue to put the values into our stem and leaf plot. So if you would like to take a moment to try that out on your own, I encourage you to pause the video here, and when you've completed, you can unpause and check your work to make sure you made a correct stem and leaf plot. And here's my completed stem and leaf plot. Now, one thing I'd like to point out is that when I make my stem and leaf plot, my goal is to get a real quick image of the graph. What this means is that I did not take the time to arrange my leaves in order from smallest to largest. For example, if I look at that first row for the 6, my leaves are in the same order that I found them, 4, 9, 9, and 8. Some teachers might ask you to put the leaves in order from least to greatest, starting at the stem direction. In other words, they might ask you to rearrange these leaves so that they would say 4, 8, 9, 9. Similar, where we have the stem for the 8, they might ask you to put them in order 2, 3, 3, 8 instead of the order that you found them in. Same thing with the 7, but that row was just much longer. I didn't want to read all of that out. In this case, if I were going to be presenting my graph for professional reasons, so maybe if it was part of a presentation or it was going to go into a paper, then I would absolutely want to put my leaves in order. If I'm just trying to get a quick general overall shape of the data set, however, I don't have to put the leaves in order. I can just keep them in the same order they showed up. It may also be useful to have data arranged in order from least to greatest. For example, in Module 3, we'll discuss some different kinds of measures of center and measures of position, like the median or percentiles. And both of those kinds of information require a data set to be in order from least to greatest. If I was creating a stem and leaf plot for that purpose, then I would definitely want to make sure my leaves were in order from smallest to greatest. Now, we were directed not only to make a stem and leaf plot, but also to identify the shape of our graph. In this case, it may be easiest to identify the shape by rotating the graph 90 degrees. When we rotate the graph, we want the smaller stems to end up on the left-hand side and the larger stems on the right-hand side. Then we can think of the set of leaves as bars, like on a bar graph. So if I were to fill in these values with bars, this is what my stem and leaf plot might look like as a histogram. In this case, it's clear that the really tall bar is on the left, and the shorter bars stretch out towards the right. So the shape of this graph is skewed right. Now that we have the basic idea of a stem and leaf plot down, let's do some variations. The first kind of variation we can make is called a split stem and leaf plot. This is particularly useful if your stems do not have a very large range. Here's how we can still make a stem and leaf plot for those values. In this example, we have the ages at which each of the 44 presidents before 2016 took office. We've been asked to make a split stem and leaf plot for these data and then to identify the shape. To see why a split stem and leaf plot might be more appropriate for this data set, let's begin by identifying the lowest and largest values. When I look through the data, the smallest number appears to be 42, and the largest is a 69. So if I were to make a regular stem and leaf plot for these values, I would need to have a row for the stem of 4, one row for the stem of 5, and one row for the stem of 6. When we talked about histograms earlier, we said that you probably want no fewer than 6 categories. So if I were to make a regular stem and leaf plot, I would only have 3 rows. It would be like only having 3 categories for a histogram. And when we looked at histograms, we said we should have probably no fewer than 6 categories. So a split stem and leaf plot is going to give us the ability to basically double the number of rows we have. Let's see how we'll accomplish that. To begin, since my smallest value was a 42 and my largest was a 69, I know my stems have to go from 4 to 6. So this would be only 3 rows. For our split stem and leaf plot, we're going to double the number of rows. In other words, I'm going to make sure that when I set up my table, I have 6 rows instead of just 3. And I'm going to take each of those stems for the 40s, the 50s, and the 60s, and I'm going to split them up into 2 stems each. So I'll have 2 stems of 4, 2 stems of 5, and 2 stems of 6. The way that we're going to distribute the leaves is essentially the same way that you make a decision when rounding. If I'm rounding a number, I know that I'm going to keep a digit the same if the next digit is less than 5. And I'm going to round the digit up if the next digit is 5 or bigger. So for the first instance of each stem, that's where I'm going to place all of the leaves from 0 to 4. In the second instance of each stem, that's where I'm going to place the leaves of 5 to 9. If you want to think about this in terms of categories for a histogram, our first row for the 4 really represents the numbers from 40 to 44, and the second row of 4 really represents the numbers 45 to 49. Then our third row will be 50 to 54, followed by 55 to 59, 60 to 64, and then 65 to 69. That's essentially what we're doing here. So let's place the first column of data together so we can get the hang of where to place the leaves for each of our stems. The first value in our data set is a 57. This has a stem of 5 and a leaf of 7. Since the leaf is a big number, the leaf is between 5 to 9, that means we're going to place the leaf of 7 in the second row for 5. The next value in our data set is a 61. So this will have a stem of 6 and a leaf of 1. Since the leaf is a smaller number, it's between 0 and 4, we're going to put the leaf of 1 in that first row for 6. We'll continue to place the leaves for each of the stems in the same manner. So the next number is a 57. So once again, I'm going to go to the second stem of 5 and place a leaf of 7. And then for our fourth number, it's also a 57. So I go in the second row of 5 and place the leaf of 7. If you'd like to practice filling in the leaves for the split stem and leaf plot, I recommend you pause the video here, and when you're finished, you can check your work. Okay, and there we go. We filled in all of the leaves for the split stem and leaf plot. Notice that the leaves in the first row of 4 are just the 2 and the 3. In the second row for 4, we have all of the leaves that were 5 or higher. Similarly, for the first row of 5, we have all the leaves that are between 0 and 4. And in the second row for 5, we have all of the leaves from 5 to 9. In the first row for the 6, we only have the leaves from 0 to 4. And in the very last row, we have the 8, the 5, and the 9, because these are the leaves that were 5 or bigger. Lastly, we were also asked to identify the shape of this distribution. If I look at the 2 stems for the 5, those are the 2 tallest bars, and as I move away from them, they appear to be about the same height. So in other words, the second bar for 4 and the first bar for 6 are about the same length, and the very first row and the very last row are about the same length as well. So I would say that this graph is approximately symmetric. The second kind of variation is called a back-to-back stem and leaf plot. This type of graph is especially useful if you're comparing two similar types of data sets. For example, this could be comparing men and women, or comparing two different age groups, or comparing two different teams. So let's do an example of creating a back-to-back stem and leaf plot. The batting averages for a sample of players on the Yankees and the Mets for the 2015 season are listed to the right. We're going to use this data to make a back-to-back stem and leaf plot. To begin with, I'm going to give myself some more space to make the graphs. To construct my stem and leaf plot, as always, I need to know where are my stems going to be ranging from. In this case, because my stem and leaf plot will be taking place for both sets of data, I need to find the smallest of the smallest numbers and the largest of the largest numbers in both sets of data combined. So I'm going to think of them kind of as like the same data set to begin with. As I look through, the smallest value was 0.211 on the New York Mets. So I'm going to write that down as my smallest number. When I look for the largest number, it shows up on the Yankee side as a 0.302. So I will list that as 0.302 for the largest. When I consider how this will impact my stems, the 0.211 will result in a stem of 21, and the 0.302 will result in a stem of 30. Now notice when I mention my stems there, I'm not including the decimal point. So I'm just going to start listing my stems as 21 all the way up to 30. I start out this time by making 3 columns. On the left-hand side will be the New York Yankees, and on the right-hand side will be the New York Mets, and in the middle will be the stems for both. Since I need my stems to range from 21 to 30, I'm going to start numbering 21, 22, and so on, all the way down until I get to 30. Again, notice that I'm not using the decimal point when I write my stems. Generally speaking, there won't be too much confusion about what your values actually are, but if you're concerned about that, you might include a short description with your graph saying that the stems represent the tenths and hundredths place. This would tell the reader of the graph that 21, for example, doesn't stand for 210, but instead stands for 0.21. To make the split stem and leaf plot, basically I'm just going to ignore the Mets for a moment and totally block them out. Then I'm going to make my stem and leaf plot like usual for the New York Yankees. The only difference is that I will be placing my leaves from right to left just because of the location of the stem, since it's on the right this time instead of on the left. So for example, the first value in the dataset is a 0.277. So this will have a stem of 27 with a leaf of 7. So I go down to where the stem is 27 and I just write a leaf of 7. The next value in the Yankees dataset is 0.250. So I go to where the stem is a 25 and I write the leaf of a 0. If you'd like to fill in the rest of the stem and leaf plot for the Yankees on your own, this would be a good place to pause the video. Then when you're all done, you can resume the video and see if your work matches mine. Okay, here we go. Okay, and that's it for the New York Yankees. Next, to complete the back-to-back stem and leaf plot, I need to uncover the Mets, and now I'm going to hide the New York Yankees. I'll continue to make my stem and leaf plot exactly the same way as before. So I'll graph the 0.259 by going to 25 and putting a leaf of 9. Then we'll graph the 0.281 by going down to 28 and putting a leaf of 1. Again, if you would like to make this stem and leaf plot on your own, you can pause the video here, and when you've finished, you can check your work. Alright, now that we're all done, let's compare the two sets of data. By making a back-to-back stem and leaf plot, we can easily compare the batting averages of the New York Yankees to the New York Mets. For example, we can see that the New York Yankees tend to hit, on average, a better batting average than the New York Mets. In particular, the New York Mets had 3 players who batted a .21 something, either a .211 or a .219. Meanwhile, the New York Yankees also had the highest value of a .302. We can also see that the New York Mets batting averages are a little bit more spread out than the New York Yankees, just by looking at the back-to-back stem and leaf plot. In terms of shape, the New York Yankees have a clear skew to them. However, it's easy to get the direction of the skew for the Yankees incorrect. When you rotate the graph for the New York Yankees, you want to rotate it so that the smaller stem, in this case the 25, is on the left-hand side. So here's what that would look like. So when I rotate the graph, it's kind of like an upside-down bar graph, where the bars are extending below and to the right. In this case, we can see then that the New York Yankees would have a skewed right distribution, because the short bars are all on the right-hand side of the really large bar. This concludes our video about stem and leaf plots. If you'd like to watch the previous video on histograms for grouped data, you can click on the arrow to the left. In the next video, we'll be discussing how to read information from pie charts and time series, which are two other types of graphs. Thanks for watching, and have a wonderful day!